Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 7.3, Solving Systems of Equations by Elimination. So far we have learned two different methods for solving systems of equations. We can graph the two equations and find the intersection point. Intersection point. Or we can solve using substitution, which is the last unit we just worked through, last section we just worked through. Today we're going to learn a third way. One name for it, obviously, if you look at the title, would be elimination. Or, as it's also known as, linear combination. Both names will make sense, but elimination will just be easier to remember. Sometimes it's easier to use one way or the other, but no matter what method, the answer will always be in an ordered pair. It will always be an ordered pair. To use elimination method, the blank of either x or y must be the same, so that's going to be the coefficient. And I don't like the fact that it says same here, because really what it means is that they need to be opposite of each other. So right opposite above this. Yes, it needs to be the same number as far as if I have a 2x and a negative 2x, that will work, but not 2x and 2x. That's not going to do anything for me. So let's go ahead and look at example 1. You'll see what I'm talking about here in 1 second. All right. Use elimination to solve each system of equations. What you're really doing here is we're adding these two lines together. Now, if I add these two lines together, I would get a third line, right? But I want to, when I'm adding them together, I want to get rid of one of my two variables. So right now I have a negative x plus a positive x. That will get rid of my x's, right? Don't scratch those out right now. Just realize that they're gonna cancel out, okay? Then 2y plus negative 5y would be negative 3y. 6 plus 9 would get me 15. Then I would divide by negative 3. So y would equal negative 5. The reason why I told you not to go ahead and cross those out is because at this point we need to plug the negative 5 back in for y in one of the two equations. You always want to look for which one is going to be easier to finish off. I'm going to choose the bottom line because my x is positive. I'm not going to have to divide by a negative 1. So what I'm going to do is the same thing we would have done if we had the substitution method, is I'm going to rewrite my new equation with negative 5 in for y. X would equal, or x plus 25, because negative 5 times negative 5 would be positive 25. Subtract the 25. X would equal negative 16. So my ordered pair would be negative 16, negative 5. So what we just did there is we're trying to add the two lines together. One of my two variables must go away. So that means I need the opposite coefficient. Not the opposite reciprocal, just the opposite. So in problem 2, I have positive 4x and I have negative 4x. Those are opposites, okay? When they're opposite like that and we add both lines together, we're going to end up getting rid of at least one of our variables. When we get rid of one of our variables, then we can finish the method, okay? Let's try number 2. I have 4x plus negative 4x, so those are going to cancel out. I have negative 5y plus 5y, so those are going to cancel out. If all that cancels out, I'll end up with 0 on the left-hand side. 3 plus 7 will give me 10. Well, 0 does not equal 10, so I'd have a no solution, just like we always would. Okay? Hopefully you're starting to understand how these can cancel out from one another. All right. Problem 3, I have 5x and 6x. If I add those together, I'll end up with 11x. I have positive 3y and negative 3y. That would get me 0, so I don't need to write it down. 4 plus 18 is 22. If I divide by 11 to solve for my x would equal 2. Now I need to put 2 back in the equation. The place I'm going to put it, since I'm replacing an x, I'm going to put it in the top equation because my y is positive up there. I don't really like to divide by negative numbers. So I would do 5 times 2 plus 3y equals 4. Well, 5 times 2 is 10, plus 3y would equal 4. If I subtract 10 from both sides, I'm going to bring this up here, that would get me 3y equals negative 6. If I divide by 3, y would equal negative 2. So my ordered pair would be positive 2, negative 2. And that would be my answer. Okay? On to problem 4. Do I have either variable as an opposite? In this case, I do not. So what I'm going to do is I'm going to multiply one of them. Well, what I'm looking for at this point then is, do I have the same number or the same coefficient on either variable? Well, I do with the y's. I have a 2y and a positive 2y, right? I need to make one of those negative. In order to do that, what I will do is I'll multiply the entire second equation by negative 1. That would get me positive 2x minus 2y equals 2. Okay? Now I'm going to add this line and this line together. So 3x plus 2x would be 5x. Positive 2y minus 2y would get me 0. 7 plus 2 would get me, I apologize, this should be negative 2, so it'd be 7 minus 2 would get me 5. The reason why that should be negative 2 is I multiplied the entire equation by negative 1, so all of their signs should change. Okay? So now I go ahead and divide by 5, x would equal 1. Now, when I go back to plug this in, I'm not going to put it into that new equation that I made up by multiplying by negative 1. So me personally, since I had messed with this line, I'm going to put it back in that line just because I know that I didn't do anything to that line. So I'm going to do 3 times 1 plus 2y equals 7. 3 times 1 is 3 plus 2y equals 7. Subtract 3. 2y would equal 4. Divide by 2. Y equals 2. So my ordered pair is 1, 2. And we're done. All right. On to a sort of a story problem. The sum of two numbers is 42. How can we write that algebraically? I have to use two different variables when I do this because it's two different numbers. So it'd be x plus y equals 42. Their difference is 6. So x minus y would equal 6. Find the two numbers. Well, this is the same thing that we've been doing the entire time. I have a positive 1y, a negative 1y, so I have opposites. That means I can go ahead and just add the two lines together. So 2x would equal 42 plus 6 is 48. Divide by 2 on both sides. X would equal 24. Now that I know what x equals, I would go back and use the x plus y because my y would be positive. So it would be 24 plus y equals 42. Subtract 24 from both sides. Y would equal 18. And we are done. So my ordered pair then would be 24, 18. Okay? Our answers should always be in ordered pairs unless, what are the two times that I would have exceptions? If I had a no solution or all real solutions, okay? Or infinite solutions, whichever you prefer. Well, that is the end of the lesson. The most important things to remember here are when I'm going to use elimination, I need to have opposite coefficients for either my x or my y. Then I'm just going to add my two lines together. That's why it was called linear combination. I'll add my two lines together. That should get rid of one of my variables. When one of my variables are gone, I can solve for the opposite variable, plug that back in to solve for my other variable, and I will be done. All right. Make sure that if you have any questions on this lesson, you go ahead and bring them to me. Otherwise, thank you very much for watching the video, and have a great day.